Okay, ladies and gentlemen, we are back 10.2, the third part, part C. And this last thing we have to do is called rationalizing the denominator. Now, to explain what that means, it basically means that we cannot have a square root sign on the bottom of a fraction. Okay, the denominator is the bottom. We can't have any radical signs down there. Now, to make this easy, again, recommend you pause the video and copy those lists down. Okay, all your perfect squares from 10.1. If you need them, excuse the paper shuffling, but they are right here. Okay. And then we also had more paper shuffling, all of the simplifying variables from that cheat sheet here in your 10.2b video notes. Okay. So you've already got all that stuff written down somewhere, hopefully. If you need to, pause this video and get those copied down again. Now, how to rationalize the denominator. Step one, when you have a square root in the denominator, multiply the top and bottom by that square root, okay? If you multiply the square root of 3 times the square root of 3, you get 3. So the square root sign just goes away, but anything we do to the bottom of the fraction, we have to do to the top, and that's where that's coming from, okay? So a lot of words. Let's see what it actually looks like in practice. We have number one, actually is very simple because both of these, if you have them memorized, you'll realize, they're already perfect squares, okay? And this will happen occasionally, right? So the square root of 100 is just 10, and the square root of 121 is just 11. Walk away, you're done, okay? Is that gonna happen a bunch? No, but you should always be on the lookout, right? That's why I say memorize those lists or always have them handy. Number two is more like a lot of what you're gonna see. You've got the square root of 75 over 3, okay? Now, the way I usually do this is I split this up, okay? So I'm gonna rewrite this as the square root of 75 over the square root of 3, okay? Now, the reason I do this is because sometimes we can ignore the whole multiply top and bottom part if we simplify the top and bottom first, okay? So the square root of 3 is a prime number. It's really small, so I know it doesn't have any perfect square factors, but square root of 75, if I remember correctly, 75 is also 25 times 3, so 25 is a perfect square. So I can rewrite this as the square root of 25 times the square root of 3 over the square root of 3, okay? So all I've done is rewritten the square root of 75 as the square root of 25 times the square root of 3. Same thing we've been doing in the two previous sections, but what's really nice about this is square root of 3 divided by square root of 3 goes away. Now all I have left is the square root of 25, which is just 5, okay? How neat is that, right? And what's nice about these problems is there's multiple ways to go about them sometimes. For example, some of you might have been really sharp and you might have said, hey, 75 divided by 3 is 25. Oh, square root of 25 is 5. Like, you don't even have to do as much as we did, okay? So while, yes, we say step one, when you have a square root, multiply top and bottom by the denominator, a lot of times you can get around it, okay? This is not one of those times we're going to have to do the multiply the top and the bottom, though, okay? So, again, I start off by simplifying the top and the bottom, okay? And the first one, it was really easy. The second one, a little more tricky. This one, we're going to have to do a little bit of work. Square root of 2 is already square root of 2. There's nothing we can do there, so that'll just stay as a square root of 2. But on the bottom, the square root of 8, we think about factors of 8 that are perfect squares, we should hopefully come up with the square root of 4 times the square root of 2, okay? Now, just like in the previous problem, I got square root of 2 on the top and square root of 2 on the bottom. So those do cancel out. And since there's nothing left on top, I just have 1 over the square root of 4. But this is the rationalizing the denominator part really coming into play. I can't leave this, I can't leave this like this. But lucky for me, I know what the square root of 4 is. It's just 1 over 2, okay? So we still, even after 3 examples, have not had to multiply top and bottom by the denominator. That's fantastic. But again, always have to be ready for it because we will see problems like that, okay? I think it's going to happen in number 4, okay? Pause the video if I'm moving too slow. Square root of 64 over the square root of 5, number 4 here, okay? Again, I split it up, square root of 64 over the square root of 5. Now, if you've got your numbers listed or memorized, you're hopefully looking at the square root of 64 and you're saying, oh, 64 is a perfect square. So the square root of 64 is just 8 over the square root of 5. Square root of 5 is a radical. It's in the denominator. It doesn't cancel out like it did in the first 3 problems. So now, finally, we have to do the multiply top and bottom by the square root. But it's not that difficult, okay? Here's what we're going to do. We're going to literally do what it says. Multiply the top by the square root of 5 and multiply the bottom by the square root of 5, okay? Again, what this does is it cancels it out, right? Square root of 5 times the square root of 5 is just 5, okay? That's kind of like the definition of what a square root is. And again, if you don't believe me, I got no problem proving it with my calculator. Boom. Told you. Told you. So, square root of 5 times square root of 5 is 5. So we just end up with 8 times square root of 5 on the top, which we don't have to do anything with. We just leave it just like that. Okay, we're not going to simplify that any further. It doesn't. Over 5. And the only other thing we'd have to do is we'd have to check if 8 over 5 simplifies at all, but it doesn't. So we're good. That's our final answer. So what are we doing if we're trying to look at this holistically? We are splitting the top and bottom into their own radicals, simplifying the top and bottom if we can. In this case, the top simplified, the bottom one didn't. And then when that bottom one stays a radical, that's when we have to multiply top and bottom by that radical, by that square root, okay? Pause and see you can think. And moving on to number 5. Same process, but now we got a variable. Don't freak out. We're going to be okay. Square root of 42 times square root of x over the square root of 2. Splitting everything up into its own radical, right? I want to use the same process we've been using in our other videos on this problem set, okay? Square root of 42. Sloppily written, but we've still got to split it up, okay? I'm thinking about my factors of 42. You can write them over here if you have to. I'm going to because I don't trust myself. 1, 42, 2, and 21, 3, and here it is. Here it is. 6, no. Gonna check. 42 divided by 3, 14. Oh, man, so close. And 42, no, 4. Is there a 6 in there? I think there is. 42 divided by 6, 7. Okay. Now, this one's interesting because we list all the factors out, and lo and behold, none of them are perfect squares. That will happen sometimes, okay? None of these are perfect squares, so I can't simplify square root of 42, okay? Doesn't happen a lot, but it happens, okay? That means, since none of this simplifies, square root of x doesn't simplify, then my next step then is to to rationalize square root of 2. So I'm going to multiply, actually, let's rewrite it down here all together. Okay, try and keep things neat. And then multiply top and bottom by the square root, okay? Square root of 2 times square root of 2 is 2. And then we've got square root of 42x times square root of 2. I don't have to write this as 2 separate steps, but what I do need to realize is I am going to multiply 42 and 2 together, okay? So that'll come out to the square root of 84x over 2. And I'd like to say that we're done, but if I want to fully simplify this one, I then have to look at that square root of 84 and say, okay, 42 didn't have any perfect square factors, but does 84? And yes, it does, okay? off the top of my head, I know 4 is going to work, right? 84 over 4 is 21. So there's only going to be the 1, but I do got to factor that out, okay? So this becomes, and I'm going to edge this over into this direction here, we get the square root of 4 times the square root of 21, and we'll just leave the x under there. It's not going to go anywhere. All over 2, okay? And square root of 4 is 2. So we get 2 square root of 21x over 2. And then you remember in the previous problem I said check if 8 over 5 simplifies. 8 over 5 doesn't, but 2 over 2 does. Matter of fact, they cancel out. So my final answer, yikes, all comes down to just 21 over x, or square root of 21 over x. Okay? Yuck. But those are rare types. You won't see as many of those, or at least I hope you won't. And if you do, I'm sorry. Okay? That's a long one. There's a lot into that one, especially with all the simplifying with the fractions at the end. But again, pause, rewind, ask questions if you need to. I know that one's a lot. 6, a lot simpler, okay? 6 to finish it up here, and I'm going to draw kind of a little box to help separate things so we don't get too confused. We've got the square root of 4y squared over 16, square root of 16. Simplify top and bottom first, just like we talked about. Square root of 4, square root of y squared over square root of 16. This one works out kind of nice because square root of 4 is 2. Square root of y squared is y. Square root of 16 is 4. So we've already gotten rid of the radicals. I'd like to say we can walk away, but we got to look at 2 and 4. 2 over 4 simplifies to 1/2. Great answer. I know you're following along. So we get 1y over 4, or just y. Sorry, we get y over 2. Trying to over-explain it. I'm tripping myself up. Whew, how about that? Guys, that's all we got, okay? We're just trying to get rid of that radical sign in the denominator. Again, sometimes like 1, 2, and 3, it takes care of itself, right? It simplifies out. We do other basic math. It cancels out with a radical on the top. A lot of times we can get rid of it. But also a lot of times we're going to have stuff like 4 and 5 where we have to do a little bit more. We have to multiply that top and bottom by the radical sign, or by the square root, let it cancel out that way, and then simplify further from there. You know, there's no one way to do these problems, and so each one's going to be a little bit different, but if you approach it with the same idea, multiply top and bottom by the denominator when you need to, simplify everything first, right? Simplify the top first, simplify the bottom first, then multiply top and bottom if you need to. You'll be in good shape, okay? Reach out to us if you have questions. Let us know how we can help. And good luck finishing up 10-2. We move on to a new section next time, I promise. Good job.